right. Simon, thank you very much for taking your time. Even though I arrived quite late with the traffic jam on the German Autobahn, here at the prefab of the FFB. And yeah, let's talk about battery innovation and battery research as such. But before we jump into today's topic and what the prefab is all about, let's talk about your path into the field of battery innovation.
Yeah, for me it was quite a strange start, I would say.
Okay.
I studied technical chemistry in Graz,
Mhm.
and then normally in the fourth semester, so exactly 20 years ago, I should have entered the organic chemistry lab,
Okay.
but due to some grading issues and some other stuff, I didn't get a spot. So
Mhm.
then I had the chance to do instead the inorganic technical chemistry lab with Professor Besenhardt and Professor Winter, and there
Okay.
quite the focus was on batteries, supercaps,
Professor Winter, of course.
and I remember still today how I built my first coin cell in the glove box in Graz in 2004. And then with a collaboration of Warta, we got little Warta cells we could play around and work with. And from that time on, I was hooked, because bringing the chemistry really into a product which works, how you can really build it together. And then you see you have a potential, you can discharge it, you can charge the battery. That was for me the moment when I started with batteries. And since then I've worked as student assistant. I did my master on batteries, and now 20 years later I'm here.
Nice. That sounds really inspiring. And maybe those to really quickly, as you explained, the 20 years in between, what were your steps in the intermediate steps on the way leading up to the Fraunhofer Forschungsfabrik? Because, I mean, you came from Graz to Germany, so curious how that evolved.
Yeah, so basically I finished then my master's, at that time diploma in technical chemistry in Graz in 2008. And then with Professor Winter, a few months after he moved to Münster, I followed and did my PhD here in 2011. So when the meet was built 15 years ago, I was one of the first PhD students working in the building.
Okay.
And then after PhD, it's always the question, what do you want to do? And my partner and I, we wanted to have experience abroad. So we were discussing about Australia or the US.
Wow.
And due to some good coincidence, it was then the US. So I moved to Berkeley, working there at the Lawrence Berkeley National Lab for some US government, US DOE funded projects, 2 years as postdoc. And then the next decision, do you stay in academia? Do you go to industry? I went to industry, working for BMW of North America in the Silicon Valley, doing technology scouting, working with startup companies there to bring their technology into BMW. And with the technology, you also need knowledge. Technology is not only plans, formulas, but it's also the knowledge in the head. So when I was in the Silicon Valley, getting all the knowledge, getting all the interaction with the startups, at some point I decided to bring the knowledge in my head also to Munich. So I moved to Munich, to BMW Germany, working there for then different departments at the end, mainly for the high voltage safety of the i4, i7 and XM. Yeah, and 3 years ago, I basically heard about this opportunity in Münster, and after some discussion, it was a no-brainer for me and my family to join this opportunity here in Münster, because it's you saw it on the tour, it's a great facility, and for me it's an opportunity to really bring the knowledge gained over 2 decades now into something to accelerate the European battery value chain, work with young people, work with engineers, bringing really technology to life, also sharing the knowledge. And that's what basically is drives me and is a big part of what I want to do.
So yeah, thank you for giving us the introduction. And the next point I would like to understand is the key innovation that you now with the FFB put forward on helping our industry, especially also in Germany, to build up, to bridge the knowledge that we gain in research to industry, because I think that is the function of the FFB, but of course you can explain this in further detail.
Yeah, I would actually not explain it in detail. I would explain it very simple.
Okay.
So if you cook at home and you make Italian pasta, I grew up at the Austrian-Italian border, like to eat Italian dishes. If you make Italian pasta at home, you make a little bowl. and you make the best recipe ever.
Okay.
But you make 200 grams, 300 grams, maybe half a kilogram. And then you want to transfer your recipe to the world. What is the world? Most likely Paria, 2.5 kilogram packages per second. If you come with your bowl from home, a plastic bowl with half a kilogram, and say, yeah, you can put this on your machine and you can spill out 2 packages of this per second, everybody would say you're crazy. In the meantime, from your kitchen at home, you need a bigger kitchen. You need to go 5, 10 kg. Then you need another kitchen to be at 100 kg. And then still you need to industrialize the process to really go into this big scale food production.
Yeah.
And we are doing the same with battery technology. Maybe in your lab, you did a coin cell. Maybe you did a single layer pouch cell. Maybe you synthesized 1 gram of cathode material. What we want to try is help researchers, help innovators all around Europe to bring their technologies closer to industrial application. This is the one part of the story. The other part of the story is somebody has already innovation, like a machine or something working, and he wants to apply it to a battery industry. Then we take this innovation into our line and try to make it ready for the battery industry. So on the one hand side, we want to be technology driven, bring technology to the market. And on the other hand, we want to be market driven, where we bring really market technologies, existing technologies, into the field of battery cell production.
Okay. So you're working on both ends, then I can understand this correctly. So one is the product side and one is the process side. Can you explain in detail what this means for the location here? So I understand you have the prefab and you have the fab. So how are you contributing to the innovation of the product and the process in the prefab? But then later also, what I saw, you have the construction site here already being also built up in the fab. So to give us an overview about the functionalities here.
And the prefab, it's also again very simple. We have 18 machines, a whole value chain, all European machines, and we can build around 80 to 100 large format cells per day, all in a clean and dry room. And what we can do is, for example, bring new, very sensitive materials into the process. We can work with new drying technologies, adjusting the coater. We can basically tailor everything around the process, but only to a certain stage. The machines are not interlinked, the processes are not interlinked, but we have each process step already under good control. So the technical readiness level is pretty high. But this doesn't guarantee a reproducibility in a gigafactory, because there all the processes have to be linked. All the steps have to be tailored to each other. And that's what we're doing in the fab. So basically in the prefab, you can go production ready. You can get 100, maybe 1,000, maybe even 1,500 cells from
day?
a big... No, 100 cells per day. So for 1,500 cells, maybe we need to produce 3 weeks or 2 weeks if we prolong the working hours or so. But in the fab, then you can go basically for thousands of cells. And there we will have a production speed of around 1 part per minute. And if you then process your technology there, you're ready to be adapted in a gigafactory. So basically, process stability, process readiness here, and then really process applicability to full production speed in the fab.
Gotcha. From a business case perspective, who are the respective customers for the prefab and then for the fab? Because those are operating on different scales, right? So I assume there is a completely different set of customers that are interested in building up on your services.
If I now switch to the marketing side, in the sales funnel, we basically attract the people in the prefab. And then for the people going really forward into gigafab, we transfer them to the fab. In the prefab, we now have at the moment 48 industry projects already running. And we have different companies. We have from 2 DAX companies, we're working with several MDAX companies, but also some startups. And we're looking at the whole value chain. So it's not only if you want to have a sample cell, but for example, one of the few collaborations I can talk about is TESA. And now you're wondering, what is TESA doing? You know them for their power strips and so on, but they want to go with their products into the battery housings, isolation tapes, and so on. And so what we're doing is we are investigating with TESA how they can enter the battery value chain in the prefab level. But later, if they really have a product which they want to apply at full speed in a production line, later maybe also in the fab.
Okay. So you just mentioned the number 48 projects, right?
Mhm.
I was wondering because we toured the facility and not all processing steps are calibrated yet and up running. So are these practical projects or also kind of engineering projects which are not requiring the prefab per se? So how do I understand those 48 projects?
So there's a wide variety. And what you saw in the prefab and on the video, also your viewers and listeners will see some of the machines look already used. We had a lab already running here in Münster before we had the prefab. So for example, the direct extrusion and so on, this was already set up in a special lab here in Münster before we started the prefab. So on these machines, we already did projects. But, and there you're totally right, a few of the projects are more engineering projects. But in the engineering projects, we use the knowledge we gained setting up the prefab. How to set up the pipes, how to set up the ovens, how to work with the climate control and so on.
Okay.
Also, even our MES system, we did quite a few modifications. We have one industry partner who is now training their people to use our MES system and how this is working. And so there are a wide variety, but I would say 80%, 90% are already working on the knowledge we gained through setting up the prefab.
Okay, now I understand you. So that is the prefab, and then now we move one scale bigger. So in the, I think, almost 1 GWh range on theoretical production capacity on the fab. So who's the customer there? So you said you're trying to transfer them, but I assume that a startup will have a difficult time within like 1 or 2 years being able to finance the scaling on that level, because you need the materials, etc., to build the full cells. So elaborate, please, a little bit that we understand a little more of how you address the market there.
Yeah, I would also correct your point a little bit, because in the prefab we will have, for example, for the coating, more capacity than 1 GWh. We want to have a large industry scale coating. For the assembly later, we don't need 15, 16 identical assembly lines. We will have 1, 2, so we will in the hundreds of megawatt-hour range.
So where a normal gigafactory would then go in parallel and apply like 10 to 20 different Z folders or single stacking machines, single sheet stacking machines, you will have 1 or 2 in order to resemble the process, but not to build it up on full scale. Whereas I assume on the coating, so electrode manufacturing, you will need the coating width in order to resemble the process and also the speed.
Exactly, totally correct. And there also lies the detail. For example, now you have a new sensor for controlling the coating thickness. You don't need to pay for the whole process. You just need to pay for integrating the sensor, taking the data, and then you run it through a different project or a research project. The biggest project definitely will be where somebody wants 10, 15,000 sample cells, but I assume this will be a minority. Projects will be, for example, I need to verify a stacking device. So we integrate a stacking device in the line, and where can you integrate a stacking device where you have really less than a second per sheet and you have the input and the output. And these projects will be smaller, and I would not say that the fab is really relying on these really big projects where we make 10, 15,000 sample cells for the B sample of a big OEM. It's really more the projects where we really test smaller technology processes on the speed which is then applied in a factory, because there you can prove that the technology is working.
And if I become your customer in either the prefab or the fab, then I approach you and say, I have this and this innovation that I want to test. And I need, for example, if I want to apply a new coating technology, do it on the prefab, then I pay for the setting up and the electricity consumption, all the required energy that is needed. And do I also need staff from your side, or do I operate myself? Like how do you operate the machines there?
So here we normally use our staff, and you do in a typical Fraunhofer model. We are not profit oriented. You pay the costs you have
Yes.
for electricity, material, and so on. But there's also the possibility, if you say you want to use the coder for 2 weeks and I want to train my people on it, and my people should operate the coder, this is no problem. Then we train you for 1 or 2 days how to use it. Maybe one of our people stand next to you that in something case something happens.
Okay.
But then your people can work 2 weeks on the coder, and at the end they're even free to clean it because we want to get it clean back.
Okay. But to be honest, also from my experience, I think this sounds quite simple, but in practice, I mean, electrode manufacturing is one of the hardest steps, and especially the detailed knowledge, the experience over the years on how to calibrate the process to get to the right product specs in the end. I think this is quite challenging. So,
But I give you one example.
Yeah.
Sorry for the interruption.
Sure.
I give you one example. You have OEM with the typical setup: lab, pilot line, serious line.
Yeah.
So let's assume this OEM is building product on product and product.
Yeah.
So nobody will stop the coding device for 2, 3, 4 weeks to really train the people that they know which knob does what process does what, how all the interactions are. And that's where we come into play. So if, for example, somebody has a need to train their people for 2, 3, 4 weeks on a big device that they really know how to learn the process, we call it shop floor training, then they can do it with our machines and they don't have to interfere with their production process.
Okay.
And it's not really about then producing maybe the best thing. It's really about how the people know the machine, know the interactions, and see what is going on.
Okay, I understand you. You built up a lot of experience over the last years by setting up the lines, procuring the equipment, and you mentioned it for the prefab, it's European built. So I guess you have a good understanding of who has which competences to deliver. I'm doing this battery expedition campaign in order to understand this firsthand. You have the machines now here and gain your experience. I'm visiting them there to understand how those machines are built. So I'm curious on exchanging our impressions that we get and experiences. So do we have on every level the European competences built in order to equip the prefab and fab with the equipment needed in order to offer your business model?
I think the answer is yes, but.
Okay.
And I think that we have 95 to 98% of all the steps you need in battery production in Europe and also in world-class technology in Europe.
Okay.
The but is, I think, what is missing in Europe is a general contractor with a proven track record. For example, we have really good companies doing technologies, but we have no company really with a proven track record of setting up a whole factory as general contractor. And these companies you can find basically only in China. And then this is one of the points I think is missing in Europe to really utilize the full potential of our technologies. But for each and every single step, I think maybe here and there a little piece is missing, but overall 95, 98%, I think we will find, I'm sure we will find the technology here in Europe.
Yeah. So yeah, with your answer, you're talking also about the general industry and for setting up the gigafactories in Europe. I understand. And for setting up I mean, because your fab is almost on gigawatt scale. So how did you experience that? Also because this is a governmental funded institution, and I know it by heart from back in my days at RWTH, that it's a little bit more complex process on procuring those machines. So can you shine light a little bit quickly on how this process turns out and what decisions you made there?
Basically, we worked with a lot of companies to really get the feeling what is cutting edge. Because we don't want to buy old equipment, but we also don't want to buy something which is not proven. So it was a little bit the decision what is really, really good, but what is also something where we can trust that it will work. And from that, we derived our descriptions, and then we started the formal bidding process. This is also outside of our hands locally. It's a real the public bidding process is a normal thing. And then we have to consider all bids coming in which fulfill the technical requirements. And most of the times we had good European, German competitors. For the FAB, in a few cases, we had only international competitors.
Okay.
And then if the offer is valid and also the specs we are demanding are met, then the international competitor also gets the contract.
Yeah, this is a very interesting thing because I think at the moment, globally speaking, Europe is the only continent who is applying to the WTO rules strictly. And you're a prime example for this because you're following the rules. And this is then where it also leads to a mixture of the different nationalities coming into the FAB then, for example, correct?
And and for example, I was working in the national lab in the US, and there it was quite clear it is Buy American. And we maybe there is a very good optical company in Germany making microscopes and so on, and we wanted to buy something from them, and it was close to impossible to really get it through because it was you need to buy something which was made in America, or at least the final assembly was done in America.
To emphasize that was back in the days, and now the rules are even stricter, making it probably impossible to source globally. Understand that. So you're close between the different sectors of research, industry, and politics, I think, because as said, this is a governmentally funded institution, and the role of the FFB and under the given situation right now, we just talked about the US. If you look at China, the borders are rising, which increases our demand to build up the competence here. Maybe a stupid question, or maybe a good question. Will the FAB become a production facility at some point on industrial scale? Because we likely will need it for special applications like defense?
I think that could be only a hypothetical backup solution. But what the FAB could definitely be is the blueprint for a small scale factory.
Yeah.
Because I think you're also referring to not EVE markets, so something which is in the air or smaller things. And there, I think we will not build up the big gigafactories, but I think we need localized chains, and localized value chains and local factories. And there the FAB could be a blueprint with the machines inside, but then as you said before, then we need the parallelization of the assembly, for example. But all the machines could be, for example, proven in the FAB, the cell design could be proven in the FAB, the process speed could be proven in the FAB, and then the only thing where you need is maybe buy 5, 6 more assembly machines, more channels for the formation at the end. So I think we could be actually almost a perfect partner to set up something like this, but as a backup for normal times, I would say no.
Okay, understand that. So under the condition that we need to build in-house competences in Germany and Europe, is the FAB to be understood as a training ground also for other industry players, machine builders in Europe, to deliver their machines in a way of lending them to the facility, on training staff or for their customers, to linking processes together so that they understand upfront before installing that, even before putting out the purchase, that this chain, we're always talking about turnkey, right? So, and I see the potential of the FAB to become this facility that enables a quick and efficient process on putting together the different machines that a potential customer with his specific requirements wants to have, set it up, test it, and even while doing that, drawing out, of course, the IPs have to be clarified before that, and who takes which role in this. But alongside that, supporting with the research along the way, while setting up this one of the role models for the customers, one of the pilot lines. Do you see such a role in the future?
Yes.
Okay.
Yes, actually, we are already working with one company exactly on a project like this.
Okay, and under preparation because the facility is not built?
Here for the prefab.
For the prefab. Okay.
Already for the prefab. As you saw on the tour, we still have some space available, and one company really wants to bring in their state-of-the-art equipment, run at a high speed, so we have to do some settings and so on for the high speed, but really wants to verify the new technology here before they go into mass production. And for the fab, this will be even much bigger. I have to watch the video. That was really a good description of the business model.
Okay, good. We will rewatch that and then talk about this. But before that, I have a question, actually 3, that I also ask every guest on this expedition to get a global picture, a European vision, perspective on our challenges, on our potential, and on your call to action. So let's start off with a challenge. If you would pinpoint one thing where you say Germany and Europe are lagging behind because of, what would it be?
Long-term planning. No, sorry, because of the lack of long-term planning.
The lack of long-term planning. Okay. Can you elaborate in one further sentence? What do you mean by politics, by industry, by the financial institutions? Who is not doing the long-term planning? That's my question.
By all of them.
Okay.
So I need a few more sentences.
Of
but
course.
for example, in 2015, China decided the Made in China 2025 Act, and they run for it. It was a hard road. They had some drawbacks, but they are now there. A lot of the points in this Made in China 2025 agenda have been made.
Yeah. While the companies are also suffering, one has to say.
While the companies already suffered on the way. There was several crises and so on, but they made it over this decade.
But also still today, like many of the companies in China are not profitable.
Yeah, like besides CATL and BYD, almost nobody is profitable.
Yeah.
But they make it. And here we tend to think on very short-term basis. For financial, we need a high value of return very soon. For politics, we think about 5-10 years, but we need to think about decades.
Yeah.
And also for investments. For example, I was talking to a leader of a big bank here in Germany, and they do not want to invest in batteries because they don't know if batteries for stationary storage are a good investment over a decade, because they say maybe in 3 or 4 years the model which is used now for stationary storage is not working, so I cannot prove that it's still working in 10 years. Why should I finance a battery?
That's risk aversion, I would say,
Yeah.
and a little bit of blindness of the future perspective. But sorry, no offense to this leader of the bank institution there. But I invite him to the podcast to talk batteries.
So for example, something, if I would say I want to have a circular value chain for electrochemical energy storage, if it's lithium, part sodium, part solid state, in 2055, you need a long-term planning. You need to think, do I start with raffination from primary materials, or do I wait that I'll have a certain feed-through of secondary materials, and so on. And all this planning is not really done. Some people think about it, some regulations, and actually good regulations are in place for recycling content and so on. But this vision, where we want to go, this long-term planning, this is something we discuss, but I don't see it on the political throne.
Yeah.
Maybe also the politicians discuss it, but it does not rise to the surface.
Exactly. And because everyone is kind of tapping in the dark, that's also part of the expedition, to trying to shine light on the competence and to envision roads that lead us to success. So let's turn this positively.
Let's turn this positively. It's very simple. Let's say continent Europe, 300 million people, energy consumption roughly a bit more than today. How much do we need? 1.2 to 1.4 terawatt hours of sustainable battery production each year. It's a very simple calculation. How much lines do I need? How much raw materials do I need? You take a technology share, and you can actually, if you want to go to a sustainable circular economy value chain, in theory, you can calculate now how much kilotons of which element you need in 2055, because the demographics is not really changing too rapidly in Europe anymore.
Okay. So you mentioned 1.3, 1.4 terawatt hours?
Now 1.2 to 1.4 terawatt hours.
In the year 2000?
Anytime.
So you mean
once you reach
production capacity that
yeah.
has to be installed that delivers 1.2 to 1.3 terawatt hours per year.
And that's a
Gotcha.
conservative scenario. If everybody drives a 80 kilowatt hour car, it's more. If everybody drives a 100 kilowatt hour car, it's much more. So that's a conservative scenario. So we can discuss plus minus 10-15% easily, but this is still.
So what you're saying is that because we are those 300 million people, because those 1.2 to 1.3 terawatt hours production capacity will be needed, the likelihood that Europe will play a role in there is just too high to be neglected and to be sourced only from China.
Exactly. Imagine the black mass export, and maybe you read about it starting since yesterday. We have now July 2nd. Since yesterday, you can trade black mass in China. There is a GB norm for how to handle black mass, in which grades and so on. So basically, they are already thinking about how they will get the resources out of the old batteries in 5-10 years. And this long-term thinking is something I don't see on the biggest political scale or even on the biggest industrial scale at the moment. It's more
coming back to the challenges there. Yeah,
it's more 5 to 10 years, which is already a long time frame for normal industry and normal policies.
But that has to be understood, right? Because in the automobile game in the last decades, this worked somehow, but it was incremental progress. And now we have a disruption of the whole economy, and this has to have new strategies in order to work successfully.
Yeah, this should be no criticism, because we always tend to criticize, but it worked in the past, and it will also tend to work in the future.
But not now, because now we have the shift.
Exactly, and
disruption.
For me as researcher, it's not my duty to make a policy. For me, it's to show the numbers, and with the numbers to really help the decision makers
to advise.
Basically. To advise, yeah.
So understand. So coming to the advice. Last question, your call to action. If there would be one advice that you would give to our industry leaders and politics or financial institutions, what would it be?
That's a tough question. I would have several points. No, one
Take 5 favorites.
No, I would say we need the network, what you are doing. We need the competence, what the industry is doing and what we are in training doing.
Yeah.
But maybe we also need a certain customer base that you can build up industry with a safe customer where you have some time to develop and some time to start the engine, basically.
Okay.
Because I think a lot of projects have the problem that they need to be fast, they need to be strong.
Yeah.
And at the end, it depends on 1-2 customers. And if one of these 2 customers fades away, the project is gone. So you need 1 reliable, 2 reliable, strong customers, the network behind, and then the trust to really set up in a competent way with the right people on board together the plan.
Yeah, and to prove our European competences.
Yeah, and you said it before, but I really want to emphasize on that. I think in Europe, we have the people, we have the knowledge, and we have the machines. I think at the moment, we lack a little bit the entrepreneurial spirit, and we lack the investment, or then the willingness to risk in investment. And the recent news doesn't make it easier to convince people to invest more.
And that's why we have to spread a positive message with scientific reputation that is trustworthy. And I hope we did our job today. So Simon, thank you for showing me around.
Thank you.
What you're building up here right now to inform our field in technology, in politics, but also in the investment landscape. And then I hope, we will find a good way to a successful European battery ecosystem.
Yeah, thank you. I really enjoyed the talk, and I think what you're doing is really nice to bring a lot of people in Europe and the world together. And hopefully we can see a bright future in battery production in Europe together.
Thanks.